So in this case, we are simply going to have a continuation. We are still looking into our paper 2 revision, and that's our question 10 on matrices. Okay, this was actually, if we check our section B, it is now like that. Some other questions, you find what you were having in section A before. So that's an advantage if you've got these typical questions of this nature, guys, for you to pick up such type of questions. Okay, anyways, that was matrix A, B, and C. Then we are given to evaluate item 1, 3A minus B. So that was a direct question, guys. 3 into matrix A. You take your matrix as it is, minus 3, minus 2, 4, 1, minus the B as it is. So that is it. Remember, we have got what? A scalar, which is 3. So with the scalar, we are supposed to multiply each and every term inside. It is just like an expansion of a bracket where a bracket is given. So 3 times minus 3 was going to be negative 9. 3 and 4, which is 12. 3 and minus 2, negative 6. 3 and 1, which is 3. Then we subtract 4 minus 1, 2, 5. Okay, so let's see what are we going to have if we are to subtract these. Element to an element corresponding, the 9 and the 4, the 12 and the minus 1, the minus 6, and these, the 3 and the 5. That is how we're going to subtract. So meaning to say, using this concept, it's minus 9 minus 4. So that's minus 13, minus 9, minus 4. Okay, then 12 minus 1. So this is 12 minus 1 like this. So a negative, remember that's a positive. So that was going to be 13. Then minus 6 minus 2. Minus 6 minus 2. So that's a negative 8. Okay, 3 minus 5. So that is 3 minus 5, which is what? Negative 2. So that was the matrix that you're going to have at the end. As you can see, guys, just direct like this. You are done for 3 marks. So as for me, guys, I was going to pick such type of a question. This is exam. Exam, you don't try to prove yourself that you know. Guys, it's about passing the exam. So choose such typical questions of this nature. Item 2, that was BC, the product. Take your B as it is. That's 4, 2, minus 1, 5. Multiply to matrix C, which is negative 2, 3. So we can even tell the answer, how it is going to look like, the order from the question. First part, it's a 2 by 2 matrix. Multiplying what? 1, 2, 1 column. Multiplying a 2 by 1. So if you combine these two, all right, if you combine these two, the last part that we are seeing represents what? The order of the final answer. It's a 2 by 1 matrix. So as we are to simplify, we know that our answer is going to be a 2 by 1. So remember, row by column. Row by what? By column. Okay, that's supposed to be U, something like that. So anyways, guys, let's multiply this part, row to this column. So that's 4 times negative 2. Okay, let me just write 4 times negative 2. Then we add negative 1 and the 3, negative 1 times 3. Okay, so we are done with this row and this column, as you can see. Then we move on to the last row. But as you can see, guys, we still have this column. So that's 2 and what? Minus 2. You multiply those 2 plus 5 and what? A 3. Just like that. So you're going to combine these, and that was going to be negative 8 plus minus 1 and 3. Remember, you are still combining there. That was going to be negative 3. Negative 4 plus what? Plus 15. Okay. So let's do combine this and have our 2 by 1 matrix. So remember, negative and a positive here will give us what? A negative at the end. So that's minus 8 minus 3. Remember, we have combined this. So it's now minus 8 minus 3, which is minus 11. Then here, minus 4 plus 15, that was going to be what? Positive 11. So we're done. Just like that. Then find the inverse of matrix A on the part B. So as we had our matrix A, we need its inverse, the inverse of A. Okay, the matrix A, remember, it was given as -3, -2, 4, 1. So for us to have the inverse of A, we must have the determinant first of A, which in the order of the matrix A, B, C, D, like this, we can have it calculated from the formula AD minus BC, the product. So you multiply AD like this, minus what? Minus 3 times what? Times 1. Minus BC, 4 and what? 4 and -2. So that was it, -3, -8. So that's a plus here, which was going to be 8 minus 3, which is what? 5. We have the determinant. So therefore, the inverse of A can be determined, where the inverse is 1 over the determinant. 1 over the determinant. Then what is going to happen? The major diagonal interchanges. So it will be dA. The minor diagonal, you multiply by a negative. So it will be minus B minus C. So this is the inverse of what? Of A. 1 over the determinant of A. So meaning to say the determinant is there, which is what? 5. So that's 1 over 5. What is going to happen? As we can see, we changed positions, the D and the A. So that's 1 and minus 3. The minor diagonal is now minus B. From the B, it's now minus. You multiply by a negative. So a 4, you multiply by a negative, it will be what? A -4. The -2, you multiply by a negative, it will be a +2. So that was the condition of our question. We've got the inverse. Then they are saying here, hence or otherwise. Hence or otherwise. Solve the simultaneous equations. Why are they saying hence? Why is the hence there? Because hence it's a continuation from what you just obtained. Okay, let's see, maybe somehow here, we are going to have something familiar to the matrices that we had before. A, B, or it's part of C. So let's see. Okay, let's see this one. Okay, because we are dealing with matrices, you want to focus on the hence. You continue with the part of what? Matrices as you had it. The otherwise, look for any other way, guys. Is it substitution method, elimination, anyone that you want? Solve this, you are done. You are not limited to what you have been doing before. You're under matrices. I was having matrix A, matrix B, so they want me to use those matrices. Yes, it is for the hands. The otherwise, it is now in your hands. Okay? So if we were to use the matrices, remember, we're going to take the constants as they are for x -3, -3, -2, the constants here. This is 1, so that's 4 and 1. We multiply to the xy is equal to, we have the matrix for these 11, 4. Know the method. So this is our matrix method. So if we check the -3, -2, 4, 1, this matrix and this matrix, these are the two that we can figure out from the hence if we had any of these two. Okay, so let's check which one do we have. According to these matrices A, B, C that we are given, which one corresponds? It is the matrix A. As we can see it, it is exactly matrix A. This part that we are seeing here, this one, as it is here, it represents the matrix A as it is before this whole section. So that is where the hence now part is going to play a role to say, since it represents matrix A, we are not going to recalculate what we are supposed to calculate here. what is it that you're supposed to calculate? Remember, you must find the inverse first. The inverse, find the inverse of A. You must find the inverse of what? Of A. The inverse of A. So are we going to calculate it? No, because here we calculated the inverse of matrix A. Remember here. So that is where the hence part is now playing a role. You are going to take that inverse of A as it is. You do not recalculate, but in a normal sense, you were supposed to calculate that inverse. Then after calculating the inverse, what is that you do? You multiply by the inverse, both sides of the equation. You are going to take this equation as it is. Remember, this is matrix A. You take the inverse of A times your matrix A times the xy that we are seeing here, okay, is equal to the inverse of A times what? 11, 4. This is what was going to happen. You take the inverse. Remember, it's an equation. What you do on the left-hand side must also be done on the right-hand side. So let's take our inverse because we already calculated it before. This one, it is already there. All right, so let's see how it was going to look like. So that's our inverse. Remember, it was 1/5, 1, 2, minus 4, minus 3 times the matrix A as it is, minus 3, minus 2, 4, 1 times xy. This is equal to the inverse of A as it is. Remember what you did on the left-hand side. So you take that inverse as it is, 1/5, 1, 2, minus 4, minus 3. We multiply to what? To 11, 4. So this is the case. So we can see that you have got the inverse here. This is the same inverse. You just multiply it on the left-hand side and also on the right-hand side. But doing this, so we have played, the nth part has played a role. Where? Not calculating this. Imagine if you do not read this, you don't figure out that it is a matrix that I had before. You're going to recalculate the inverse, guys. You are calculating what you did before. So they don't want you to do that. That is why they put this word hence, because they know you calculated something about that question that you are to calculate now. They are not going to tell you from where. Is it from B? Is it from item A or what? You are the one who is supposed to figure out where the hence was. Where am I taking it from? So that is it. So let's continue, guys. We do understand an inverse of a 2 by 2 matrix when multiplied to its original matrix. It gives us an identity matrix, 1, 0, 0, 1. So here we are not going to waste our time multiplying these two. It's a waste of time. It's the image versus its object there. We are talking about the inverse of A and the matrix A. This is what we have. So we are not going to do a repetition of multiplying this. No, guys. We have it already that we are supposed to get what? An identity matrix there. So you just write the answer 1, 0, 0, 1. Don't waste your time multiplying those. Times xy is equal to, on this side, we can multiply. So let's ignore the 1/5. Take it just as a scalar. So we take 1/5. We ignore that. We just multiply as usual, guys. Row by column. Remember your concept. So we're going to take this row to this column. Let's multiply and see 1 times 11. That was 11 plus -4 and 4. That was going to be what? -16. Okay. We move on to this row, but still same column. Okay. So that's 2 and 11, which is 22 plus -3 and 4, which is what? -12. So that is what you were going to have. Then you can combine the right-hand side. On the left-hand side, do not even worry because we have an identity matrix which multiplies xy. An identity matrix, when it multiplies a certain matrix, the answer is going to be that matrix that you're multiplying A. So if it is multiplying this, it is going to remain as it is. If it is whatever the identity matrix multiplies, it remains as it is. So we are going to simply work out the right-hand side. Okay, 11 plus minus 16, that's in negative 5. Then 12 and negative 22 minus 12. So that was going to give us what? A 10 there. So that's it. XY is equal to 1 over 5. You multiply the scalar now inside. The scalar must multiply everything that we see here. So that's 1 over 5 times negative 5, which was going to give us negative 1. And 1 over 5 times 10 was going to give us what? A 2. So that's it. This is what we're going to have. We have got the values of x and y. So x corresponds to what? To negative 1. And the y value corresponds to what? To 2. So this is how we can have these questions attempted. You choose to work with the hence method. The hence, it is a continuation from what you had before, what you're working with before. But otherwise, it means we can have these simultaneous equations answered in any other way. Is it by elimination? Is it by substitution? Any way that you want. So let's see, just prove. So in this case, I'm just going to use substitution method, guys. We have got equation 1 and we've got equation 2. So here I'm just going to use the substitution method. Method. So working with the substitution method, it is easier for me to make y the subject of the formula from equation 2. As we can see, y here is on its own. We're just going to take negative 2x to the other side. So it means y is equal to 4 plus 2x. If we take the negative 2x, it will be a positive. So we now have this one as our equation 3. We made y the subject from where? From equation 2. This is where we made y the subject. So we now have equation 3. So what is it that we are going to do? We are going to substitute equation 3 in equation 1. Don't substitute where you made the subject. You substitute in the other equation. If you made whatever that you made the subject in equation 1, you substitute in equation 2. But here we took it from equation 2. So we must substitute in what? Equation 1. So substitute whatever that we are given on equation 3, all right, into equation 1. So meaning to say in place of y, which is 4 plus 2x, we are going to substitute in place of y in what? Equation 1. So meaning to say that was going to be minus 3x plus 4y. So take note, it's 4y there. The y part is the one that we are going to substitute with this equivalent that we are seeing here, which is the 4 plus 2x. So this is equivalent to what? It is equal to 11. We have formed an equation which is only in x. We no longer have two unknown values in this equation. So it is easier for us to solve for x, as we do understand our linear equations, guys. Expand brackets, collect like terms. Negative 3x. So distribute by 4. 4 times 4, that's positive 16. 4 and 2, that's positive 8. Positive 8x, which is equal to 11. Then we've got like terms, the negative 3x and the 8x. So negative 3 plus 8 was going to give us 5x plus 16, which is equivalent to 11. So 5x is equal to what? Taking the 16, this one to the other side, it was going to be a negative. The moment it crosses the equal sign, it will be negative. So that's 11 minus 16, which is negative 5. So divide by 5. That was going to give us what? Negative 1. So we have got the x value. With this x value that we are having, substitute it now in any one of these equations. Equation 1, equation 2, equation 3. It is in your hands now. You choose. You are going to have the same value of y. So why bothering equation 1 and 2 there? Where we still have complications. We can work with what? Equation 3. Where already y is the subject. Already y is the subject. It is just to substitute here in equation 3. Already y is the subject. So just substitute the value of x that you obtained in place of x. What is the x value? -1. So that was going to give us the value of y there. So 4, and that was going to be -2. So that's 4 minus 2, which is what? Which is 2. Just like that. So these are the typical questions that you must try to work out as you are doing your revisions. Try by all means to work out typical questions like these. Choose the method that you do understand. It is not about matrices here. If you understand elimination method, use that one. Anyone that you understand, anyone, as long you are good at that method. That is the otherwise. Unless that statement here was not there, this one. If they limit you now here to hands, guys, there is no way. You must use what you have been working with before. You are under what? Matrices. So you must continue using the matrices. So it means matrix method as way of solving simultaneous equations. It's part of your syllabus. You're supposed to know it because they can avoid that. It's possible. So do revise, guys. All these methods, you're supposed to know each on how to solve simultaneous equations. Each method as it is in your syllabus. So that is it for this class. Let us continue revising, preparing for the exams which are ahead of time.